the writing of my Cosmology of Light books. So, as I've shared, I wrote 10 books in Cosmology of Light. And these books I would really categorize as an artistic expression. So, I was trying to capture my perception of the power and possibility in light. And these had, I would say, resulted from some experiences I had of light when I was younger, and which I continue to have through the years, that I'll share a little bit about some other time. But the point is that those books were all a spontaneous expression of something that I wished to capture in a framework, and I found mathematics to be a means by which I could more fully articulate what I was feeling about light. Now, that may seem counterintuitive, but somehow the language of mathematics gave me a certain fulfillment in capturing the concepts that I was trying to summarize. And it's not that I was a mathematician, I've never been a mathematician, but I think the knowledge that I needed to articulate myself surfaced at the right time. And so I was able to launch on this journey of writing these 10 books. And I'll share a little bit about that journey some other time. But today, what I wanted to focus on was this parallel track that I've been on. So while the Cosmology of Light books have been an artistic expression, at the same time, I've pursued an academic track. And I'm going to share the writings that have been instrumental over the last couple of decades in informing the final Cosmology of Light framework that I've completed this year. When I use the word final, I should perhaps never use the word final, but at least the 10 books that have framed my perception of light today. Now, let me just pull up this website here, and I'm going to scroll through it. And it's a rather long read. It's about 18 minutes, so I'm not going to go through this in entirety, but I'm going to pick up some key points that occurred along the way. And I'll say that the articles that all show up here, so they're not just articles, they're also presentations from conference proceedings and papers written for that were presented in conferences. And in addition, there were a series of peer-reviewed books that showed up in, or rather were published by a global academic publisher, Sage. And so I want to share a little bit about that. So about 20 years ago, or rather in about, I would say 2002, so almost 20 years ago, I had been involved in management consulting for a few years. And so my headspace had been more or less focused on business and on business transformation. And one of the problems that I worked on quite a bit for a few years was essentially that of transforming a business to move into a new market or to create new products. And at the time, I was part of A.T. Kearney, which is a global consulting company, and I was part of a team to set up an office in India. And this was, I would say, in that period of about 2000, where India was just opening out to the global market. And as a result, there were a lot of changes that were required, not only by Indian companies, but by companies that wanted to establish a foothold in India. And therefore, this problem of business transformation was very real. And so I spent quite a few years on that. And as a result, my head was focused there. And so the first couple of articles that I wrote that were published in a SAGE journal, Journal of Human Values, had to do with that problem that I was trying to help solve, which was how do you create efficient, sustainable business transformation? And it struck me that this could be done through the creation of what was called a complex adaptive system. So, complex adaptive system itself is a relatively fledgling field, and perhaps it began to take a more precise shape around that time, around 2000. But somehow I tapped into that, and so the very first academic paper that I wrote was called Business Transformation through the Creation of a Complex Adaptive System. And the relevancy of this to light is actually something that did not occur to me for many years. So I went along this path almost in a blind manner. But as I began to understand subsequently the nature of light and the pervasiveness of light, then in my formulation and articulation of light, there was nothing that could or should be left out. So all phenomena, all emergence on this physical plane, no matter what it is, so whether we're talking about micro emergences at the level of the human cell, or we're talking about a complete human being, the emergence of a human being, and the complex psychology that accompanies that, or we're talking about a human based organization and therefore business organization, these to me are all emergences from light, and they're infused with light. And therefore, there is nothing that's not within the domain of light. But when I wrote this paper back in 2002, it got published in 2003, I didn't know that. And that's the very interesting thing, because a number of papers that I wrote, and then even the books that I wrote, didn't have any mention of light, but they became an integral part of the framework that I subsequently developed that has to do with a cosmology of light. So this notion of complex adaptive system, it very simply, it can be thought of as a system that can sustain itself. So regardless of circumstance, it can meet circumstance, it can assimilate the forces that are changing things, it can adapt so that it has a response to those forces, and as a result, it remains to be a living entity. And the question is, what are the characteristics of such a system? And if we could gain insight into that, what the characteristics are, then essentially we have a formula or a framework that would allow organization, regardless of the type of organization, to continue to exist in harmony with both those entities that or components that make it up from the inside and the larger system within which it exists, which is I think a fundamental, and it's a eons long problem. We can extrapolate that to civilization, to countries, and in a sense it boils down to this problem: how do you maintain this equilibrium so that there is a harmony at the many levels of granularity that animate a system? Now, if we can figure that out, then that's a huge step forward, practically speaking, along many different realms. And it is, I would say, would become a driver for sustainability along many different fronts. So the problem was very interesting. And so I put together some initial thoughts, and that was accepted for publication in the Journal of Human Values. Subsequently, and related to was this notion of fractals. Fractal is a pattern that repeats itself on different scale. And my point of view, adaptive systems, and which I've continued to articulate through the years, is that there are certain base patterns that exist, for example, in the level of the individual. So it might be in our thoughts, in our assumptions, in our perceptions. And these patterns take on a life and they animate how a team might operate, and they will animate how a business unit might operate. They will animate how a corporation conceives of itself, and also how an organization meets the market. So basic patterns that can create a lot of complexity. And so to understand how a pattern at one level, so at the individual level, relates to the team, relates to the organization, relates to the market, is a problem in fractal dynamics. Said a pattern that repeats itself on different scales. So this was also something that interested me deeply, and it was perhaps a particular and that I continued to develop over the years. But that paper too was accepted for publication. And then, interestingly, on the strength of these two papers, which were very popular at the time, in terms of the number of views that they had in terms of the number of downloads. And so I approached Sage and proposed a series of books to do with fractals, and that proposal was accepted. And so for the next almost decade, I was involved in the writing of these three books, but these were academic, peer-reviewed books. And the first book was called Connecting Inner Power with Global Change, and this was finally published in 2009. So it's one thing I learned about academic publishing as far as it comes to books, and certainly my experience of it has been that there's a long period that you have to wait years before your book comes out. I mean, first you write the book, which takes at least a year, and then you give it to the publisher, and then there's a back and forth that involves many people. There's the whole peer review, so they send it out to a bunch of professors around the world, get feedback, you make changes, and then it goes through a whole editorial cycle. And by the time that book comes out, it's 2 years later. And so it's a long gestation period for any book to come out. So the three books that I wrote weren't completed till 2015, even though the initial papers were published in 2003 and 2004. So connecting inner power with global change, really, in that what I did. So it's an academic book, and I proposed a theory of organization in which fractals were instrumental, and also there were particular kinds of fractals, or a particular kind of fractal that I proposed is required for sustainability to be realized. So sustainability on the human dimension, or on the ecosystem dimension, or the social dimension. But sustainability, it's the same kind of pattern that you need to see it regardless of the avenue or dimension of sustainability that you're concerned with. And so that book really proposed a theoretical framework for employing fractals in organizations, but it remained theoretical. And the second book, which was Redesigning the Stock Market, what I really wanted to do was apply this fractal framework to a real world problem. So in principle, when Sage and I entered into a contract, it was for three books, but the subject matter wasn't decided. So it was something that could evolve. And we had the global financial crisis occur in 2008, 2009, and the after effects of that continued for a couple of years. And so, what I wanted to do was apply this fractal framework to this problem of the global financial crisis. And to me, the heart of the problem was the attitudes, the perceptions, the way of behavior of organizations, of markets that had the stock market at the center, because the way that stock markets function, they propagate a certain mentality, and that mentality to me is short-sighted and creates a lot of the continuing problems that we have, again, on the social, on the economic, on the ecosystem front, on the organizational front, and so on. And so what I sought to do was apply this fractal framework to redesigning the stock market. And so that was the subject of this second book. Once this book came out in 2011, I was invited by a journal called the Integral Review to summarize some of the concepts there. And I essentially proposed that one of the fundamental problems that we have when we think about markets is that we use the same instruments, the monetary instruments, to try and solve market problems, regardless of what caused the market problem or regardless of the nature of the market problem. And my proposal was that, in fact, we have to do it differently, because when we think about market crises, when we think about crashes that occur, they are all of a different nature. And in the book Redesigning the Stock Market, I proposed an arc of development which was linked to this fractal that I had proposed in the first book, that's required for sustainability to exist. So a certain kind of pattern that's required for sustainability to exist over a longer term. And so in this summary paper, what I wanted to do was look at or summarize the different kind of market crashes that began in, I use a time period from around 1970 to about 2010. And so it was a 40-year period. And my hypothesis was that these market crashes were all symptoms of something, of a trend, of a longer term trend. And you had to understand that long term trend, which was a system trying to push everything along this fractal for progress. Once you see that, then the way that you address the market crisis can change. And so that's really what this paper, which was a result from the book, really focused on. And then in 2015, I came out with the third and final book in this Sage series, and it was called the Fractal Organization, which really had three parts to it. So one was that it summarized the fractal framework, the theoretical framework that I had proposed in 2009 in connecting inner power with global change. It had a second part that I created in coordination with somebody from Stanford University Medical Center who I had been closely involved with at the time. And we created a field guide, if you will, for applying fractal thinking practically in organizations. And so that second part of the book was a field guide that I had created with this individual. And then the third part of the book was taking the cue from the second book, Redesigning the Stock Market. What I wanted to do, or what I did, was there were a number of practical applications or ways to think about contemporary global, regional, national problems, no matter what part of the world we looked at. And so that's what I did. I applied this fractal framework to a number of contemporary problems. So these may be problems about socioeconomic stability in some part of the world, or there were problems around theoretical frameworks that, in my opinion, had been were stuck. And so I was just trying to use a fractal framework to address many of these practical problems. And so that's what the third book was about. So it had a very practical component to it. And I ended up getting this award for this best book award that I got from the International Association for Management of Technology in 2016. And then, interestingly, um, a professor in South Africa, uh, Dietmar Winsker, Dr. Dietmar Winsker, he read my book Connecting Inner Power with Global Change, and he wrote me a 20-page letter, um, just highlighting things that he agreed with and highlighting things he didn't agree with. And we entered into a long distance dialogue. And that dialogue led to my embarking on a PhD, because he he basically let me know that his PhD advisor, and he had done his PhD many years ago, but his PhD advisor was essentially reaching the end of his career, Dr. Leon Pretorius, who ended up becoming my PhD advisor, and I did a PhD under him at from the University of Pretoria. And I'll speak about that some other time in more detail, as well as it relates to some of the foundations of the cosmology of light. But essentially, I had around this time, so I would say around 2013, 2014, awoken to the power of math, and I felt a very strong urge to express the work that I had begun doing and the work that was encapsulated in these three fractal books in a mathematical way. And so things just came together. So there was this over the next few years, and my doctoral focus was essentially around using math to frame how innovation occurs in complex adaptive systems. So fractals were an integral part of that. This notion of resilience, of changing markets. How do you capture all that mathematically? And how do you create a fractal mathematical framework that can be true regardless of the level of granularity? And so that's what I ended up doing my PhD in. And there were a number of papers that we produced that were published in both journals and in conference proceedings that essentially expressed that math. I always partnered with Professor Dr. Leon Pretorius, but on several of these papers, Dr. Dietmar Winsker was also a partner. And so several of these papers, the three of us worked together. And then for a number of other papers, it was just Professor Dr. Leon Pretorius and myself. But qualified determinism in, let me go back, I think I skipped a couple of papers here, but there was a paper, the mathematics in complex adaptive systems, and oh yeah, here it is. Sorry. So essentially, in 2014, as I said, I began this PhD degree, and in 2015, we published our first joint paper, A Mathematical Basis of Innovation, that its scope, or really what it was focusing on, was this idea of using a mathematical framework to understand innovation, regardless of the kind of system or organization uh, we're concerned with. So whether it's a market system, whether it's a corporation, whether it's a cellular system at the level of the human being, or in a plant or in an animal. So essentially, this mathematical basis of innovation was meant to be agnostic to its field of application. It was some universal principles of innovation that were tied to a mathematics that underlay it all. And then there were a series of papers that were also published. There was qualified determinism in emergent technology, complex adaptive systems. And essentially, my point of view on complex adaptive systems and what I wrote about in those three books was basically that you have to look at the complex system from the top down. Now, the prevalent thought and the academic trend was to always consider complex adaptive systems from the bottom up. And that, by definition, when you look at when you try and understand something from the bottom up, it's going to give you insight into certain kinds of dynamics, and there's going to be a certain narrative that arises, and that narrative is going to have to do naturally with probability and uncertainty, because you're not seeing the whole picture, and it looks like there's a bunch of kind of non-connected individual things that appear to be acting in a random way, and therefore, probability and uncertainty become a key theme of all this. And yet there are some aggregate patterns due to statistics, if you will, that emerge from this randomness, and that's how you begin to see some order in a system when you try and conceive it from the bottom up. My approach was the exact opposite. It was to look at a system and try and see patterns across a longer time frame, and compare patterns across space, so in different markets or different regions of the world, and then extrapolate certain biases or certain fundamental or implicit characteristics of any system that is operating in a resilient way, and then attribute those findings or properties to the system itself. So you're looking at it from the top down, and so there's a different kind of analysis, and therefore there's this notion of qualified determinism that surfaces, where it's the opposite of uncertainty. You're saying that there is a determinism, but it's qualified because there's a number of different forces that are active, and if you understand all those forces more completely, you can in fact predict, or you can see which force or which trend is likely going to emerge within that particular system. And so qualified determinism is something very different from the current narrative that animates thinking about complex adaptive systems. In 2017, I also completed the PhD thesis, which actually was titled "Development and Evaluation of a Framework for an Engine of Innovation in Complex Adaptive Systems." And but it had to do with the mathematics of innovation of any complex adaptive system. And along the way, interestingly, I applied that to several areas. But one of the presentations that I gave was the application of the system of innovation, the mathematical system of innovation, at the cellular level. So regardless of whether a living cell exists in plant, animal, or a human being, there's a particular kind of innovation that occurs there. And so I framed that through this mathematical framework that I had developed in this PhD, and applied it, and I got this award for best presentation in a doctoral research colloquium. I'm not going to go through all the details of this PhD. I'll just summarize. I'll say there were about 225 equations that were developed in 25 different areas, and these were all uniquely derived based on the math and the application areas were vast. So as I said, there were 25 different areas in which these equations could be applied. And subsequently in 2018, we published with Professor Dr. Leon Pretorius, published this paper that ex post facto, based on some of the work I had done at Stanford University Medical Center years ago, um, that had to do with innovation, because I had built a software tool that allowed teams to operate more innovatively. And so I retrospectively applied the model of math that was implicit in this operation to show how you could deliberately create a complex adaptive system, essentially by allowing teams to operate in a certain way. And when you allow a team to operate in a certain way, there's a particular kind of mathematics that um, you can make emerge, and that mathematics can contribute to innovation when you aggregate it out across a larger organization. Um, you know, the interesting thing, I want to just pause here, is that all this work, this formulation of complex adaptive systems, of the math in it, of the fractals, this was all really fundamental, or a fundamental part of the cosmology of light framework that I then began to work on once I had finished my PhD. And this the fascination with light as this entity that's ubiquitous, as I've shared else in other live streams, and of course in other presentations and writings, is there's no escaping light, in a certain way of saying, because all atoms of animate matter, of inanimate matter, are forged in the light of the suns of the math of a supernova. And so, by definition, there's a deep signature of light that exists in everything that exists. And so, light is in everything. And so, we need to think about light differently. And light definitely has a tremendous power. We've tapped into it technologically in our application of the electromagnetic spectrum, which is nothing other than light. We've created so many technologies that animate how our world operates today. It creates the infrastructure that, whether it's our cell phones, or computers, or it's aircraft, or it's just broadcasting, there's so many different applications that emanate from light itself. And this is all happen, in a sense, kind of unconsciously. We don't really know, in a sense, what we're doing, or what we're tapping into, or this tremendous thing that light is. And so, really, what is light? I mean, that's what the question comes down to. What is light? And in my perception, light is the basis of existence. Everything emerges from light. Everything is light. Everything is an application of light. And if we consciously tap into what light is, then the very nature of our existence can change far more radically, and rapidly, and sustainably than we can imagine. And so the power that exists in light is fractal. The power that exists in light can drive, or can animate, any complex adaptive system. Any complex adaptive system, by definition, since it has maintained its resilience and sustainability, is a more successful emergence from the possibility of light. And so we want to understand more clearly, what are these successful emergences from this field of light, and how do you consciously create them? And so a cosmology of light looks at light much more comprehensively, and tries to understand the dynamics, the practical dynamics of things from the point of view of light. And so there's, as I said, I went along the development of fractal dynamics and complex adaptive systems in an almost blind fashion, but it all kind of dovetailed into this body and this understanding and this framework of light that then I subsequently, now having both, I would say, more of the intellectual capacity, more of the instruments available to me in terms of a mathematical expression, some of the earlier experiences that I had of light as a child and subsequently could then be articulated more fully, having gone through this decades long journey. If I step back and look at my own journey in the articulation, from the point that perhaps I began to have some experiences of light, it's been 5 decades. So I began to have some experiences of light when I was a very young child, 5, 6, 7 years old, as far as I can remember. And some of these continued through the years, but I clearly didn't have the instrumentation or the kind of capacity to even understand or articulate anything. But it takes decades to develop that kind of thing, and not that I have some extraordinary capacity right now, but certainly it's better than it used to be 5 decades ago, or 3 decades ago, or 2 decades ago. And so I felt more confident to actually embark on this journey of creating these 10 books. But the parallel track has been these academic articles that have all kind of dovetail into this body of the cosmology of light. In 2018, though, I began to also publish a number of papers that were much more, or were light related. So if we look at some of these articles or papers that came out in journals, so in this Indian Journal of, let's see, so in this Indian Journal of Science and Technology, I published a paper, and this was again with Professor Dr. Leon Pretorius, Symmetries of Light and Emergence of Matter. That was the first overt paper to do with light. And then I published a paper, The Fourfold Composite Quantum, the Emergence of Space-Time, Energy, Gravity, and Some Implications, in a Journal of Pure and Applied Physics. And the notion of space-time, energy, gravity is fundamental to any kind of narrative on cosmology or cosmos. And so a cosmology of light can only emerge once you have some kind of descriptions of what space-time, energy, and gravity are relative to light itself. And so this was something that I articulated here academically. And then there's a number of papers again that were more directly to do with light. So here's a derivation of quaternary-based mathematical operators to manage innovation in complex adaptive systems. So this was more a management of technology problem, but again, could be entirely applied to light. And I did adapt this in the Cosmology of Light books. We have also an algorithm for the emergence of life based on a multi-layered symmetry-based model of light. And I published I presented this in 2019 at IEEE, the CCWC conference. And also in 2019, there was a mathematical paper that looked at a different structuring of the periodic table. And again, this was something that was very consistent with the framework of light. And in 2020, there's been a few more papers that have been published to do with light itself, light-based interpretation of quanta and its implications on quantum computing. So as I had suggested in a previous live stream, the four books on cosmology, on the applications of cosmology of light, had to do with quantum computing, genetics, artificial intelligence, and transhumanism. But what I've also sought to do was publish academic papers that took key ideas in these books for, again, for peer review and for different commentary by at least some of the academic community. Um, and then subsequently, more recently, there was a paper, Light-Based Quantum Computational Model of Genetics. And interestingly, which I completely didn't expect, I got the Best Presenter Award at this conference. I never expected it because when I'm writing about light, or when I'm articulating this mathematical framework of light, it's on the fringe. It's not something that certainly has not been accepted by mainstream academia, and so it's on the boundaries. But it was good to have that kind of feedback. And then more recently, I published a paper, Limits of AI as Established by Multi-Layered Symmetry-Based Model of Light. And again, I got the Best Presenter Award. And this time, I guess I was less surprised. It felt really good when I gave the presentation. It felt like I was hitting home on it. So that was a good acknowledgement. And we also, another partner, academic partner of mine, Ms. Lalita Nalamutulu, we recently published Fourfold Properties of Light and its relevance to quantum computation. These papers are very recent, so they haven't shown up on the IEEE Explore Index yet, but they will in a couple of months. And there's still more papers to be published that really bring out some of the key ideas in the cosmology of light. And certainly academically, that's where I'll be focusing on in the next few years.